Good afternoon. This is the review for Unit 6, Test 1. So Test 1 of 2 tests. We'll have our second one in several weeks, but for right now we're going to fill in the information for this review. So the first section is the rational parent function section. It should be on page 72. It's the very first set of notes, 6-1. Asks us to graph and identify the key attributes of the rational parent function. Remember that the rational parent function is called a hyperbola. The equation is y equals 1 over x. Remember that rational indicates fraction, so 1 over x is the fraction. The domain and range are both all real numbers. However, there is an area that is undefined in both the domain and the range. In the domain, the domain is all real numbers, but the x value cannot be 0. And in the range, we have all real numbers again, but the y value cannot be 0. And the reason for that is whenever you graph it, you're going to have asymptotes at the place where x equals 0 and y equals 0. So x and y axes are going to be approached, but they're never going to be crossed or touched. Which leads us to the intercepts. There is no x-intercept, and there is no y-intercept. And before we talk about the asymptotes, I'd like to actually graph. And so in order to graph, I need to make a table. I can create x values. I'm going to pick some negative, some positive, but I'm definitely going to pick -1, 0, and +1 because that's going to help me with some nice pretty points towards the center. So I'm going to pick -9, -3, -1, 0, and then those same numbers, but their positive counterparts. And remember, when you substitute the x values into the equation for the rational parent function, the y value ends up being 1 over whatever the x value is. So if the x value is -9, the y value is -1 over 9. If the x value is -3, the y value is -1 over 3. If the x value is -1, the y value is -1 over 1, which is just -1. If the x value is 0, then the y value is 1 over 0, and you cannot divide by 0, so this is the undefined location. When x is 1, 1 over 1 is just 1. When x is 3, y is 1/3. When x is 9, y is 1/9. So if I go plot those ordered pairs, so I can create ordered pairs here, I'm going to have to estimate with the fractions, but that's okay. -9, -1/9, -3, -1/3, -1, -1, 0, nothing, that's undefined because there's an asymptote there. 1, 1, so here's that location. 3, 1/3, and 9, 1/9. And if I look from my notes on page 72, I'm going to see that my graph kind of looks like this. And here it's not intended that they touch, it just, my pen kind of got away from me. So there we go. So this is your hyperbola. And I need to talk about the asymptotes. Remember, the asymptotes are the places where the graph approaches but does not touch. So the vertical asymptote is going to be the vertical line that the graph approaches but doesn't touch. It's right here. And that vertical asymptote happens to be the line x equals 0. The horizontal asymptote is in a similar situation, it's just horizontal. So that line is y equals 0. And that is precisely why the domain and the range are all the real values except when x is 0 and y is 0, because when x is 0 and y is 0, there are asymptotes. So the graph does not touch. It approaches but does not touch. So we're going to shift to long division. So our long division is on page 73. The long division steps are first to divide, then to multiply, then to subtract, then to bring down, and then to repeat that process as many times as it takes to get a remainder or to find out that the remainder is 0. So important things to remember is to make sure you check for missing terms. So if I start out with an x cubed term, then I should then have an x squared term, an x term, and a constant term. If I don't, then I need to insert a 0 term. So check for missing terms. I don't have missing terms here, so I'm going to go ahead and set up my long division. So 4x plus 1 goes on the outside. And 8x cubed minus 10x squared plus 17x plus 5 goes on the inside. So whenever I divide, I'm only dividing the first terms. So 8x cubed divided by 4x. 8 divided by 4 is 2. If I take x cubed and I divide out an x, I'm left with x squared, so that's going to go in as part of my answer. I divided. I'm now going to multiply, but when I multiply, I'm distributing. So I'm multiplying 2x squared times 4x and 2x squared times 1. Now I want to subtract, so I'm going to draw the line. I'm going to change both signs. Make sure you scratch out the old one and put the new one. So these two cancel out like they're supposed to. Negative 10x squared minus 2 more x squareds is negative 12x squared. I saw a lot of people just put 12x squared today. Make sure you include that sign. And finally, you want to bring down your next term. You want to do it all over again with the first term. So you're going to divide negative 12x squared divided by 4x. The negative stays. 12 divided by 4 is 3. X squared divided by x is x. So minus 3x will go on the top. I'm going to multiply. Negative 3x times 4x is negative 12x squared. And negative 3x times 1 is minus 3x. So I multiplied. I want to subtract, so I'm going to draw the line. I'm going to change both signs. These two will cancel like they're supposed to, and 17x's plus 3 more is 20x's. Then I bring down my next term, which is plus 5. Make sure you bring it down with the sign that connects it. So if it had a minus 5, I would bring down minus 5. And then I start my process all over again. So 20x divided by 4x, equals 5, positive 5, so I'm going to put plus 5 here. 5 times 4x is 20x, 5 times 1 is plus 5. I'm going to draw the line. I'm going to change both signs. Oh, I shouldn't have checked that yet because I didn't subtract. 20x minus 20x cancels. 5 minus 5 is 0. That's my remainder. So my final answer is 2x squared minus 3x plus 5 with no remainder. That is my final answer. So I'm going to flip to number 3. Keeping in mind important things to remember that I need to check for missing terms. I've got an x cubed, I've got an x squared. I do not have an x before I have a constant, so I need to insert here a plus 0x. So when I create my long division problem, x plus 2 is going to go outside. And on the inside, I'm going to have x cubed minus 6x squared plus 0x. I need that placeholder, and then plus 1. Again, my steps are to multiply, or sorry, to divide, to multiply, to subtract, and to bring down. So, to divide, x cubed divided by x is just x squared, so that goes up in my answer. And multiply, x squared times x is x cubed. X squared times 2 is plus 2x squared. I need to subtract, so draw the line, change both signs. X cubed minus x cubed is canceled. Negative 6x squared minus 2 more x squareds is negative 8x squared. Then I'm going to bring down my plus 0x. I'm going to start it all over again. So negative 8x squared divided by x. I keep my coefficient, and x squared just becomes x. So that goes up top. I multiply. Negative 8x times x is negative 8x squared. Negative 8x times 2 is negative 16x. I want to subtract, so draw the line, change both signs. Negative 8x squared plus 8x squared cancels out. 0x's plus 16x's is still a positive 16x. And then I bring down my plus 1. And then I start all over again. So 16x divided by x. That's just 16. So a positive 16. 16 times x is 16x. 16 times 2 is plus 32. Draw the line, change both signs. 16x minus 16x cancels. 1 minus 32 is negative 31, which is my remainder. And I need to remember to write remainders over whatever I'm dividing by, so x plus 2 in this case. And I also need to remember to either add it or subtract it. So in this case, since 31 is negative, I'm going to subtract it. So my answer should be x squared minus 8x plus 16 minus 31 over x plus 2. So it is part of my polynomial. I do need to add or subtract it. So in this case, since it's negative, I'm going to put minus. If this would have been like a positive 8, then I would have put plus 8 over x plus 2. So moving on to synthetic division. Okay, synthetic division is on page 74. There's also a video in Schoology. The link is in Schoology, but it's on my YouTube account. If you want to go back and look at the synthetic division lesson, I think most people enjoyed it. So synthetic division, you have to remember kind of the same thing that long division you had to remember, which was you need to rewrite polynomials with 0 terms before setting up your synthetic division. So I notice in number 4 that it goes straight from a power of 5 to a constant. That means I'm missing a lot of pieces in the middle. There's a lot of 0 terms. So I'm going to go ahead and rewrite them because in my synthetic division, I need the coefficients of all of those terms, and there's going to be a lot of zeros. So x to the power of 5 plus no x to the power of 4s and no x to the power of 3s and no x squareds and no x's, but then a minus 1. So when I create my synthetic division setup, the opposite of x plus 1, or sorry, of x minus 1 is going to be a plus 1. And I'm going to put all my coefficients, so a 1 in front of the x to the power of 5. 1, 2, 3, 4 zeros. 1, 2, 3, 4. And then finally a minus 1. For synthetic division, the first coefficient you bring down. And every time you bring something down, you multiply it with your r value before putting a new value here. So 1 times 1 is 1. Add this column. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 1 plus 1 is 0. So this is my remainder, no remainder. When I start writing my answer, I need to go ahead and make this the coefficient of the x term that has 1 less power than what we started with. So we're going to start out with x to the power of 4. So this is 1 x to the power of 4 plus 1x to the power of 3 plus 1x squared